Hi team, thanks for giving me the opportunity to share my vision of a math initiative with you that I'd like to work on this year. After I finish my presentation, I'm hoping that some of you or all of you will decide to join me. So I'm going to go through the slideshow presentation and basically talk about what I'm hoping to work on this year. So I wanted to start with, I think we're already doing a great job of teaching math skills. We're using explicit teaching, manipulatives, visuals, playing math games, connecting math to literature. We're providing a lot of opportunities for our kids to practice math in a varied way. An area that I'd like to work on is this last one, providing problem-solving opportunities. And the reason this came up for me is I've been taking some math courses at Queen's, and I came across this video by Dan Meyer, and basically it's about math class needing a makeover, and it had me questioning, am I providing the kind of problem-solving questions that will help my students become problem solvers? And the reason I started thinking about that is because the kind of problems I had been presenting them with were things like, Lisa has 32 cookies and Steve has 56 cookies. How many cookies do they have altogether? And I'm thinking, does that actually make them problem solvers? Or does it mean they can read a question and pull the numbers out and add them together? So Dan Meyer, in his video, which you should watch later, I'm going to send you the link, says there's 5 things you'll notice if your math teaching isn't working for your students. So 1, they have a lack of initiative. They don't want to do math. 2, a lack of perseverance. So they'll get started, but when things get hard, they just stop. Lack of retention. You know how sometimes you're thinking, did that teacher last year even teach them this? Because these kids don't remember anything. Well, we are all teaching them what we need to teach them, but they're not remembering, so lack of retention. Aversion to word problems and eagerness for a formula. Basically, they're looking for the easiest way to get the job done. So, why do I want to work on problem solving? What are the benefits of providing real-world, authentic, open-ended problem-solving activities? Well, there are many. More student collaboration and dialogue about math, students taking the initiative to solve problems, working through struggles, and trying multiple methods and persevering, transference of math skills that are applied in multiple real-world situations. This is a big one for me. Can they take the math that they know and actually use it? Students can do math when faced with a new situation or problem. So something comes up, they need to figure it out. Can they take the math they know and use it in a situation they've never faced before? Students will understand the math, not just know how to calculate the answer. It actually meets the core and curricular competencies better than what I've been doing so far. So if you look at them, all of those things can be covered by doing this problem solving. And it's actually what happens in real life. When you need to use math, you aren't given a worksheet, you're faced with a problem. So if I have something, I'm building a garden bed in my yard and I need to figure out, I want to have, like 3 rows of strawberries and 6 rows of blueberries. How much space do I need for that? That's not a worksheet, that's something I need to actually be able to figure out. So you're thinking, Lisa, how are you going to do this? Well, my hope is to set up an inquiry project. So an inquiry project for teachers looks just like it does for kids. You start with something you're wondering about, you think about what you can do, you experiment, try things out, you watch what happens when you try things out, you record your data, you look for patterns, you interpret your data, you reflect on what happened, and then you start over with another question that came out of what you found out. So that's how we teach kids to do it. It's the same thing for teachers. So I've kind of come up with a possible inquiry question, but I'm open to changing it if people want to collaborate with me and work on it together. So my question so far is, what impact will using a collaborative problem-solving approach have on students' ability to apply math skills in real-life situations? So I kind of took the things that I thought were most important and condensed them into that question. So what's next, you ask? I've also been learning about the Japanese lesson study model, which is the method that teachers in Japan use for Pro-D. So we all know math scores are very high in Pro-D, and I was surprised to find out that 60% of children's math time in class in Japan is spent problem solving, and only 40% of the time is spent practicing. And one of the reasons for this is because the teachers follow this lesson study model. So you can see that it's closely related to the inquiry model. Set a goal, make a plan, implement it, debrief, reflect, start over. The difference with this is that teachers are working collaboratively together, researching, coming up with a lesson. One person teaches it, all the other teachers are there during the lesson, but they're not watching the teacher to critique them. They're watching the students to see how the methods worked, right? And then you can take that information to debrief and improve your practice. So in my vision, this is the process we would use to solve that inquiry question. Of course, if someone has other ideas, I'm open to that. The other thing I'm hoping to incorporate is Peter Liljedahl's Thinking Classroom. So this is basically a method for helping kids solve those authentic, open-ended problems. It's a teaching method. It's got very specific steps, which I'm going to show you on the next slide. So I'm proposing that we get copies of this book for everyone who's interested, and we kind of form a professional book club to study the idea and then look at implementing them together in a Japanese lesson study kind of way. So before I finish, I just wanted to show you kind of the basics of Peter Liljedahl's approach. So this sketch was made by Laura Wheeler, who is a big follower of Peter Liljedahl, and she kind of broke down his thinking classroom into 11 distinct ideas. So starting with a problem, visibly random groups, this is an exciting one, I can't wait to talk to you about that. Vertical non-permanent surfaces, also very exciting. The teacher gives instructions. Defront the room means the kids are kind of all over the place and in charge. The teacher's not standing in front giving instructions. The teacher is answering questions but giving hints, not answers. Building autonomy, giving hints for extensions, level to the bottom, student notes, and assessment. Now, I know that's a lot of things to take in, but I want you to see that the approach I'm hoping we can take, there is already some research and some pretty solid information that could help us get started. And last, I guess I want to know what you think. Are you interested in doing something like this? Do you have another idea of how to do it? I'm hoping that you will join me.